Hi guys, in this video we'll see electrocyclic reactions. Electrocyclic reactions are intramolecular reactions in which a new sigma bond formed between ends of two conjugated phi system. First thing is these are intramolecular reaction, and the second thing is here when a new sigma bond will be formed between the ends of this conjugated pi system here. We'll understand more by taking an example here. This is a 4-5 electron system. Here one of this phi system will be moved here, and this pi bond will be used for the formation of new sigma bond, and the product here will get is this 4-membered ring. Here there is a double bond, and this is a new sigma bond. These things will happen here. So electrocyclic reaction means intramolecular reactions. And the second thing is one new sigma bond will be formed here between ends of conjugated phi systems. Next we'll see is the properties of electrocyclic reaction. Properties. First thing is these are intramolecular reaction. Second property is these are one-step reaction. This one-step reaction is also called as concerted reactions. In electrocyclic reaction, there will be formation of one new sigma bond. Here in electrocyclic reaction, product will be containing one less pi bond. Look at here, reactant got 2 pi bond, and the product got one pi bond. Another pi bond will be utilized for the formation of new sigma bond. You know that thing. Next we shall see some examples of electrocyclic reaction. First example, 3 pi bonds are there. 3 pi bonds means you know that it is a 6 pi electrons. 1 pi bond containing 2 electrons. 3 pi bond will be containing 6 pi electrons. If we move this pi bond here, this here, and if you utilize this pi bond for the formation of new sigma, we'll get this product. Double bond will be here, double bond will be here, and the third double bond will be used for the formation of new sigma bond. Observe the properties here. First property is these are intramolecular reaction. Second thing is these are one-step reaction. Third thing is one new sigma bond formed here. One new sigma bond formed here. Fourth thing is product containing one less pi bond. Here it got 2 pi bonds. In the reactant there are 3 pi bonds. Next example we'll see is the second example. This is 4-5 electron system. 2 pi bonds are there. 2 pi bond means number of pi electrons will be 4 pi electrons. This pi bond will be shifted here, and this pi bond utilized for the formation of new sigma bond. So the product will be this. The challenging thing in this example is stereochemistry, because there are 2 methyl groups present at the end. The stereochemistry can be a cis. The stereochemistry can be cis or trans. It may be cis or it may be a trans. Both are not possible, because electrocyclic reactions or any pericyclic reactions are stereospecific reactions. In my introductory lecture I told about the stereospecific reactions. Stereospecific reactions are those in which only one product will be possible, and in that one product whatever the stereochemistry in the reactant, that will be faithfully reproduced. I talked about this thing. So as these are a stereospecific reaction, either cis or trans is only a product. We don't know which one is the product here. This We got a question here, which is the product? For this answer, the answer is selection rule. We'll understand selection rule first. In selection rule, we need to understand some terminologies. First, we'll understand the conditions of a reaction. Condition means it may be a thermal condition, or it may be a photochemical condition. Thermal or photochemical condition. Next, we'll see a systems. System may be 4n-pi system. System may be 4n plus 2-pi system. 4n-5 system we'll see first time. 4n-5 system means when n equal to 1, this becomes 4-pi electrons. So for this, an example is butadiene. So butadiene is an example for 4n-pi system. Next we'll see is 4n plus 2-5 system. When n equal to 1, this becomes 6-pi electrons. So 135 hexatriene is an example for 4n plus 2-5 system. We understood what is system and what is condition. We understood both of these things. Next we'll understand these two things: rotations, Kahn rotation and disrotation. Remember one thing, the concept of Kahn rotation and disrotations are very, very essential to understand electrocyclic reactions. Without this concept, we can't solve a single question of electrocyclic reactions. So the knowledge of Kahn rotation and disrotation is very, very important. Kahn rotation means moving the groups in one direction, either this direction or this direction. Disrotation means moving the group both inside or both outside. Remember this thing, moving both inside or moving both outside. This is disrotatory. So with this knowledge, we'll see the possibilities here. When 4n-5 system is there and the condition is thermal, we'll get a Kahn rotatory, we'll get here. 4n-pi system and thermal condition means we'll get a Kahn rotatory. When 4n-pi system and the condition is photochemical, we'll get a disrotatory, we'll get here. Next thing is when the system is 4n plus 2-phi and the condition is thermal, we'll get a disrotatory. And when the system is 4n plus 2-phi and the condition is photochemical, we'll get Kahn rotatory. With this knowledge, we can solve a electrocyclic reaction. We'll see some examples. The first example is this one. It is, you know that it got a 2-pi bonds and the number of 5 electrons here is 4 5 electrons and the condition is thermal. 4n-pi system and thermal condition means which rotation we have to do. Just now we saw the selection rule. We'll see it again. 4n-pi system thermal condition means we have to do Kahn rotation. We must do Kahn rotation here. Kahn rotation means, you know that, moving in one direction. We have to move the groups in this direction. First we'll write the basic product. This bond will be shifted here. This bond will be used for the formation of new bond. So this is the basic product. Then stereochemistry will be obtained by the moving the groups in this direction. Moving this means, consider this as these groups are in a plane of paper. We'll flip these things. If we flip means hydrogen comes above and CS3 goes below the plane of paper. Hydrogen comes above the plane of paper and CS3 goes below the plane of paper. If hydrogen comes above means this thing will happen. Next, we are moving these things. Here we are flipping in this direction means this CS3 comes above. This CS3 comes above and hydrogen goes below. So the product here is one CS3 is above and another CS3 is below. The product here is trans product. Next we'll go for second example here. This is also 4 5 electron system plus photochemical condition is there. 4-pi system photochemical condition means you have to do the disk rotation. Disk rotation means you know that moving the groups either inside or outside. I will move inside. First we'll write the basic product by using this pi electron systems. This is the basic. Then if we flip these groups inside means hydrogen goes above and CS3 goes below. Hydrogen goes above and CS3 goes below. Here if I move inside in this direction, hydrogen comes above, CS3 goes below. Hydrogen comes above and CS3 goes below. In this product, both CS3s are below. The product here is cis. We'll solve many examples in my coming videos. Thank you for watching.